So in the last video I started sheet pile walls and I found a pressure diagram like this for a sheet pile wall carrying cohesionless soil, and you had a diagram like this, active pressure up to here, and from here to here it is changing to active to passive. Again it is changing from here to here. Like this, a pressure diagram we got it. So when you consider different forces, this force, this force, this force and this force, take moment about some point and equate to all the forces, because all what we need is here what is the depth of amendment. Our aim is to find the depth of amendment. To find this one, it is very cumbersome, very lengthy calculations are there. So you will get the equation up to the power of d to the power 4. And different forces you have to consider, equate, you have to take the moments. So lengthy calculations are there. Luckily these calculations and details are not for your syllabus also. So only thing is you should know what is sheet pile wall, what are the classification of sheet pile walls, that is cantilever and anchor, and in anchor again free earth support and fixed earth support methods, and then how you get the pressure diagram for a cantilever sheet pile wall, like this, okay, for cohesionless soil. Now as I told you, the calculations are very lengthy, so one more approximate method is developed where this diagram has been simplified and calculations will automatically becomes easier. So what they do here is, suppose now this is a cantilever sheet pile wall, this is your ground level, okay, up to here the height is h, this is d, some phi will be given to you, you can calculate k and kp, all these things, the entire soil is there. So for this, so this diagram is there. But the simplified version, an approximate method is there. By using that method, the calculations will be easy. What they do know, in this method, what they assume that this entire up to bottom, they take this as active pressure, and wherever the dredge line is there, so here they will take it as passive pressure. Two forces are taken. One more force they will take at the bottom of this one. So its moment will become 0. So we are neglecting here it is. So complete active pressure is taken on the right hand side. Passive pressure is taken on the left hand side. So this is going to be small pa, that is active pressure. This is going to be small pp, that is passive pressure. So this is given by, we know that this is Kp gamma into d. Kp into gamma into d, because this d is depth of amendment, and that we want to calculate. That is our aim, to calculate the depth of amendment. And up to here, this height is h. So this one, active pressure base, is going to be Ka gamma h plus d, because this total height from here to here is Ka gamma h plus d. From the earth pressure theories, you know that this is active pressure, this is passive pressure, base of this one is Kp gamma d, whereas base of this one is K into gamma into h plus d. K into gamma into h plus d. And once you get once you get pp, suppose a point is there, suppose this point I will take as C, you take moment at the base, when you take a moment at the base, so you see for the passive pressure, this is area of the triangle's total force, that is half into Kp gamma d, this is base, into height is d. This is the total force Pp. For the triangle, if you take moment at the base, this is the triangle, it acts at h by 3, that is d by 3. It's going to be D by 3. This is for passive pressure triangle, and then active pressure triangle is there on the right hand side, and it is taken by again this equal to 1 by 2. 1 by 2. Again base here is Ka gamma. So this is H plus D half into base, and height is again H plus D, and it acts at the H plus D by 3. H plus D by 3. You simplify these equations. So here everything is known. Kp is known, depth you want to calculate, H is known, gamma is known. You substitute all the equation values, you will get equation in terms of dp, dq, and if you simplify, you are going to get the value of d. For factor of safety of consideration, you increase this by 20 to 40%. Sometimes you can increase by 20% if the value is less, if the value is more. If the value is less, you can increase by up to 40%. Up to 40%. So this is the procedure. This is the procedure for approximate. This is the procedure of approximate method to find the value of D. See, compared to the earlier one where the pressure diagrams are more and you have to find different pressures, equate them, take the moments or different values you have to take. There, getting the value of D is very difficult. Getting the value of D is very difficult. Now we shall solve the problem based on this method. Find the depth of amendment. Find the depth of amendment. Find the depth of amendment for the sheet piling. For the sheet piling shown in figure. Shown in the figure, the soil has effective unit weight of 17 kilonewton per meter cube. 17 kilonewton per meter cube. And an angle of internal friction of 30 degrees. Angle of internal friction of 30 degrees. So figure is shown here. So this is the figure. This is the ground level. This height is 6 meter. It is given to you. This is the depth of amendment you have to find. This is the dredge level. Of course, the next is phi is equal to 30 degrees. Phi is equal to 30 degrees is given to you. Phi is equal to 30 degrees is given to you. Now you see here phi is equal to 30 degrees is given to you. Means first of all, of course, gamma is also given. Gamma is 17 kilonewton per meter cube. Gamma is equal to 17 kilonewton per meter cube. Now we know that Ka, K and Kp are required here. Ka is equal to 1 minus sine phi divided by 1 plus sine phi. Therefore, Ka is equal to 1 minus sine 30 divided by 1 plus sine 30, or Ka is equal to 1 minus sine 30 is 0.5. This is 1 plus 0.5. So you will get Ka is equal to 0.5 by 1.5, or Ka is equal to 1 by 3. You get Ka is equal to 1 by 3. Once you get K is equal to 1 by 3, Kp is equal to, we know that 1 by K, therefore Kp is equal to 1 by 1 by 3, therefore Kp is equal to 3. Therefore K is 1 by 3, Kp is equal to 3. These calculations you have to make. These calculations you have to make. Okay, got it? K you got, Kp you got, H height is 6 meter. H is 6 meter, and what is the value of D? You have to calculate here. What is the value of D? You have to calculate here. So once you have now K and Kp, so now K and Kp, then we shall go for approximate method. We shall go for approximate method. So now, how to calculate the approximate method? Just to see how, first I will draw the pressure diagram. So this is there. So up to here, full bottom it is active pressure we take, and at the dredge level, this is dredge level, we take this as passive pressure. So this is small pa, this is small pp, this is small pp, and this is going to be dredge level. This is dredge level. This is the pressure diagram. Of course, one more force will come here into existence. That is a passive force only, it acts in direction. But as we are taking moment about this point, O point or C point, whatever you consider O point, so that moment will become zero. So it is not at all useful for us to find the D. So only two forces to consider. One is this active pressure. Second is this passive pressure. So this space is given by, as I told you, Kp gamma into D. This is given by Kp gamma into D, whereas this is given by Ka gamma into H plus D. Ka into gamma into H plus D. H plus D. Now first I will calculate this pressure, that is small pa. Small pa is equal to this area of triangle, and this is given by 1 by 2. Base is Ka into gamma into H plus D, and height is H plus D. Height is H plus D. So small pa is equal to 1 by 2. K is 1 by 3, gamma is 17, H is 6 plus D, again H is 6 plus D. So P is equal to 17 by 6, 6 plus D whole square, 6 plus D whole square, or small p is equal to, if you simplify this bracket, that is 17 by 6, 36 plus d square plus 12d like this. So small pa, after simplifying all these things, you will get 2.8 d square plus 34d plus 102. This is equation 1. Got it? What I did here is, I want the force, this I took pressure here is, small p is given by this area of triangle, just to find pressure diagram, half into this base, that is k into gamma into h plus d, and height is h plus d, values are known to you, K is known to you, gamma is known to you, H is known to you. You substitute all the things and you simplify. This is going to be small PA. There is a force active pressure here. This is the small PA, that is the active pressure. Now, coming to this passive pressure. Coming to this passive pressure, see here. Now, as far as passive pressure is concerned, that is small pp is equal to, again, area of this triangle. This is half into base is Kp gamma d into d. Kp into gamma d into d. Or this is equal to 1 by 2 into 3 into gamma is 17 into d square, and pp is equal to, if you simplify all these things, you will get 25.5 d square. This is equation 2. This is equation 2. This is equation 2. Now, our aim is to find the D, capital D. So, we shall take now moment of this force at this point O. So, taking moment about O, you write taking moment about O. Taking moment about O. So, when you take moment about A, you see here because of PA is here, that is 2.8 d square plus 34d plus 102 into this is a triangle, force is acting here, so this height is going to be h by 3. H means here h plus d means 6 plus d by 3. 6 plus d by 3. Because of this, a movement like this you will get anti-clockwise, and because of pp you will get a clockwise movement, and this is equal to pp. pp is 25.5 d square. 25.5 d square into, again this also acts at h by 3, that is d by 3. You see here, except d, all other things are known here. Only d is unknown, and if you simplify, multiply all these things, you will get equation 0.76 d cube minus 3.66 d square minus 10.2 d minus 20.4 equal to 0. Minus 20.4 equal to 0. If you simplify this, you will get d is equal to 7.1 meter. D is equal to 7.1 meter. But as I told you, this has to be increased by the factor of safety of consideration from 20% to 40%. So here I am taking it as 40%. Anything you can take 20, 30 or 40. I am taking here 40%. So when you take 40%, so effective depth, total depth is equal to it is 7.1 into 1.4. 1.4, and this is going to be 9.94 meter. To check it, 9.94 meter. So see here, this is very easy method, approximate method, comparing to the earlier one, where calculations were more. I think you have followed this. Now one more problem I will solve on this one. Now, one more problem we take, approximate method only. A coffer dam, receipt pipe only, a coffer dam is to be constructed of cantilever sheet piling, is to be constructed of cantilever sheet piling, full stop. It has to retain a soil of bulk density 2.3 gram per cc. Remember here unit weight is not given, bulk density is given 2.3 gram per cc, and an angle of internal friction of 33 degrees up to a height of 5 meter. Find the depth to which the piles should be driven. Assuming that two-thirds of the theoretical passive resistance is developed on the embedded length. Please go through the question. Once you read the question carefully, a coffer dam is to be constructed of a cantilever sheet. Of course, it is a cantilever sheet pipe wall. It has a soil of bulk density is given, angle of internal friction is given, height is 5 meter. Means here I will take this one. So this is your ground level. So up to here, the height is here 5 meter. This is the depth we are interested. This depth we have to calculate. Rest of the things are same. Only thing is what he has given is that this you should underline the pile should be driven assuming that 2/3 of the theoretical passive resistance is developed on the embedded. In this passive resistance you have to take 2/3 of the whatever theoretical is there. Whatever theoretical passive resistance you calculate, in calculation you take 2/3 of that one. That I will tell you afterwards. So before that one, so here phi is given. Phi is 33 degrees given. So first of all we will calculate what is K and Kp. K is equal to 1 minus sin phi divided by 1 plus sin phi. This equal to 1 minus sin phi is 33 degrees divided by 1 plus sin 33 degrees, and this equal to 1 minus sin phi 1. This is 1 minus 0.545, 1 plus 0.545. So if you simplify this one, you will get 0.294. Ka you will get 0.294. Ka you will get 0.294. So once you get Ka, now Kp is equal to 1 by K, 1 by 0.294, and this is going to be 3.4. This is going to be 3.4. In this way, you have to calculate Ka and Kp. Ka and Kp. Second thing is, gamma is not given directly here, rho is given. We shall calculate gamma here. So now gamma is given, rho is given as 2.3 gram per cc. So gamma is equal to, I think it is not visible to you, gamma is equal to rho by rho w into gamma w. This you know from the basics of geotech. So gamma is equal to rho by rho w into gamma w. Rho is how much? 2.3 and rho w is 1 and gamma w is here taken as 9.81 for water. If you simplify all these things, you will get gamma equal to 22.56 kilonewton per meter cube. 22.56 kilonewton per meter cube. So in this way, first you calculate what is gamma, what is Ka, what is Kp, what is Ka and what is Kp. The rest of the things are known. You can do it yourself also. Or as I did in the last problem, it's the same procedure you have to follow. You have to simplify. You have to get the value of D. Everything is same. Value increase by certain percentage. Now the question is given here. Up to here it is 5 meter, isn't it? So depth is D. This we want to calculate. So this is the figure. Everything he has given. I will draw the figure here. So this is active pressure up to here. So this is the passive pressure. So here small p is acting. Here small pp is acting. This is going to be as usual Kp gamma D. This is going to be Ka gamma H plus B. This is going to be Ka gamma H plus D. Ka gamma H plus D. So now I will calculate first small pa. Small pa is equal to 1 by 2 into Ka gamma H plus D into height is H plus D, and this is equal to small p is equal to 1 by 2 Ka is 0.294 into gamma is 22.56 into H plus D means 5 plus B. Again it is 5 plus B. 5 plus D into 5 plus D, or small pa is equal to, you simplify all these things, you will get 3.316 into 5 plus B whole square. This is equation 1. This is equation 1. This is active pressure. This is active pressure. Similarly, small pp is equal to 1 by 2 Kp gamma D into D. Kp gamma D into D. But the thing is, in the question it is given that the passive resistance should be taken as 2 by 3rd of the theoretical resistance. 2 by means whatever this quantity is take, therefore you take Pp is equal to 2 by 3rd of this value, that is 1 by 2 into Kp into gamma into d square. This is equation number 2. And if you simplify this one, this direct value I will give you. Pp is equal to 25.57 d square. You take this as equation 2. (25.57 d square). Now taking moment about the base C as well in the previous problem. So now what we get is PA into H plus D by 3, PA into H plus D by 3 into PP into D by 3. PP into D by 3. So PA is equal to 3.316 into 5 plus D whole square into 5 plus D by 3 equal to 25.57 D square. This is PP into D by 3. See here, you simplify this. Except D, all other things are known to you here. So if you simplify by a cubic equation, you will get. If you simplify all, you will get something D cube is equal to something like this. So from this value, you will get D is equal to 5.1 meter. D is equal to, you will get 5.1 meter. And if you increase this by 20%, 30% or 40%, here I will increase by 20%. So 1.20 into 5.1. So D is equal to 6.12 meter. 6.12 meter. Got it? So this method is called approximate method of calculating the depth of amendment in cantilever sheet pile wall when cohesionless soil is there. When C equal to 0, cohesionless soil is there. So you have to go by this procedure. So in the next video, that is video number 8, I will take now cohesive soil, cantilever sheet pile with cohesive soil. I will get the pressure diagram for that one first, and next we shall move for numericals on that one. I hope you understood this well. Thank you.